So topic of our today's tutorial is reciprocating pump. So reciprocating has mainly components as piston and connecting rod and crankshaft, which is driven by the prime mover engine. So here this combination crankshaft and the connecting rod will convert the rotary energy given by the engine towards the reciprocating energy. So this reciprocation is done at a piston, which sucks the fluid at one end, and again it delivers the fluid towards the upper side of the upper side of the play, upper side. So here we are going to discuss about discharge and work done and power calculation of the double acting pump. So double acting pump, in the previous section we see about single acting pump, but now here we see about double acting pump. Double acting pump, it will supply the fluid at both the ends. So we know already for a single pipe of suction and delivery we have two valves, but here two pipes are there. So we have 1, 2, 3 and 4 valves available for the effective movement of the fluid from bottom section towards the upper section. So piston has two sides which has different diameters. So they obviously have different areas. So left side of the piston have diameter capital D, which is fully available for the pressurization of the fluid. Whereas in the right side we have certain diameter of the certain portion is left outside. So namely the connecting rod has certain diameter. So that portion we have to subtract. So for calculation of the area of the left side, we can take the full diameter, full circle diameter. So we can calculate it as pi by 4 d square for the left side. So for the right side, it is pi by 4 capital D square minus the area for the connecting rod. So we have a larger diameter as capital D and smaller diameter as small d. So this small diameter is left over. So we have the remaining area pi by 4 capital D square minus pi by 4 small d square. So that is the area available in the right hand side. So we give term A1 and A2 for left hand side and the right hand side. So for the area A2 is pi by 4 capital D square minus small d square. So these are the areas available. So to calculate the volume of the water supplied from the reciprocating pump, double acting reciprocating pump, we have to calculate the volume of the cylinder. So for each and every evolution, the piston going to reciprocate and it occupies certain volume. So that volume we have to calculate. So obviously it is a cylindrical volume. So it has certain area and it has certain length. So by multiplying them, we can have the area available and the length available. We can calculate the volume available for the delivery. So here both the sides are there. So for volume 1 we can calculate it from A1 L1, and for volume 2 we can calculate from A2 L1. So why we put L1 same for both the things is, so piston have a constant stroke length for both the reciprocation. So for each reciprocation it will travel a length of L. So that is why we kept it as common. So in total pi by 4 capital D square into L plus pi by 4 capital D square minus small d square into L is the volume available for volume available for the fluid to fill inside the reciprocating pump. So we can simply make the L as common outside. So finally we can have this equation for calculating the volume of fluid supplied by the reciprocating pump for a single revolution. So for single revolution, that is the volume. For calculating for the entire speed, we have to first calculate the number of revolutions per second. For that, which we can calculate by dividing n with 60. So it will be equal to n by 60. So in order to find out what total volume of the water supplied every second, we have to multiply both the things. Volume of the water delivered in one revolution multiplied by RPS. So volume into RPS. So we already know what is volume. Similarly, we know what is RPS. RPS is nothing but revolutions per second. So V is volume, which is available, which is discussed already, as pi by 4 capital D square plus pi by 4 into capital D square minus small d square into L multiplied by n by 60, which is nothing but RPS. So this is the volume of fluid supplied by reciprocating pump, mainly it is the volume supplied by the reciprocating pump of the double acting type. So in comparison, the capital diameter, that is major diameter of the cylinder, is greater than that of the connecting rod diameter. So it is the connecting rod diameter is negligible when comparing to the size of the diameter of the piston. So we can easily make it as negligible and put it as 0. So finally we can have the equation slightly modified as pi by 4 capital D square plus pi by 4 capital D square minus 0. So it will not have any effect. So finally the equation will become pi by 4 in 2 into pi by 4 D square. Obviously it will become pi by 2 D square into L into n by 60. So further, in simplification, we can term it as 2 into pi by 4 d square. So pi by 4 d square is nothing but the area available in the left hand side. So we can term it as 2 into pi by 4 d square. Multiplied by L into n divided by 60. Two into pi by 4 d square into L n divided by 60. So pi by 4 d square, we know it is nothing but area of the left hand side. So generally we can term it as A. 2 into AL n divided by 60 is the volumetric flow rate of the double acting reciprocating pump. So this is the equation to find out the volumetric flow rate, which is measured in measured in meter cube per second. So this is the nothing but volume, how much the volume of fluid is pumped by the double acting reciprocating pump. By applying this equation, we can calculate for any double acting reciprocating pump what is the flow rate, volumetric flow rate. So in the next section, we have to calculate. In the next section, we have to calculate what is the work done of the double acting reciprocating pump. So work done is nothing but force into distance traveled. So force often termed as weight. So what is the weight of the fluid lifted and what is the distance it is lifted? So by multiplying both the terms, we can calculate the work done by the reciprocating pump. So what is the weight of the water delivered? So in previous equation we know what is the volume of the water delivered. That is nothing but 2ALN divided by 60. By multiplying with the rho g, we can calculate the weight of the water delivered per second. And further multiply with what is the total height. It is nothing but sum of the suction head and delivery head. So finally it is nothing but HS plus HD. So the equation will become 2 rho g into ALN divided by 60 multiplied by HS plus HD. So then HS plus HD is nothing but total head. HS is nothing but suction head. HD is nothing but delivery head. Rho is density, G is gravitational acceleration, A is area, and L is length, and N is speed in RPM. So in the next section, we are going to calculate slippage of the reciprocating pump. So what is meant by slippage? So in principle, whenever we design a pump, for example, when we design a pump for 1 liter capacity, it will not deliver in actual term, it will not deliver exactly 1 liter. Instead, it may slightly increase or slightly decrease over a time. Uh, this difference is called slip. So what is the difference between theoretical flow rate and the actual flow rate? Is nothing but slip. So it is nothing but the difference between theoretical discharge and the actual discharge. So in the next section, we are going to calculate percentage of slip. So slip is QTH minus Q actual. So in the next section, percentage of slip can be calculated by QTH by when comparing towards the QTH. So slip with divided by QTH is nothing but percentage of slip. So slip is nothing but QTH minus Q actual. Divide by QTH into 100 will give percentage of the slip. So further take dividing it, QTH divided by QTH will become 1. Similarly, Q actual divided by Q theoretical will be there into 100. So this Q actual divided by Q theoretical is nothing but coefficient of discharge. So the equation obviously would become 1 minus CD. This is CD is nothing but coefficient of discharge. So the final equation for percentage of slippage will be 1 minus CD into 100. So the final equation would be like percentage of slip will be equal to 1 minus CD multiplied by 100.